Hello, you are welcome to Maths Clinic Series. In this video, we are starting a new series called Trigonometry. So we are going to start with this topic, and it's going to be in smaller units. And so this will be the video number 1. Now, don't forget that we are still having normal class, and so you have to get your calculators, your notebooks ready. You write. Don't relax and watch the movie, watch it as a movie, but enjoy it as a normal class that I'm taking you through. All right, so we are starting with introduction. So video number 1 will be introduction. Video number 2 will be in a different subtopic in that smaller form. All right, so with this very short video, by the end of it, you should be able to define the word trigonometry, identify the applications of trigonometry in real life situation, then review the properties of right angled triangle. So these are a few things we want to look at for the first video. Is it possible to measure the height of this tower without climbing it or use tape measure? Is it possible? Yeah, it is. We can do it, and this is why we have to study trigonometry. People work on these towers and height, and they go to submarines and stuff. How do they get there? How do they measure or take measurements? They can do that using trigonometry. For example, if I have a tape measure and I measure the foot of this tower, and then maybe I present maybe someone here, we can first of all maybe presume angle of either elevation or angle of depression. We'll look at that later in the course of this particular series. And then we can create what we call right angle triangle, and then we can have series of parallel lines that can flow with the hypotenuse. Now let us assume that we take a height of someone here at this very point, and knowing the height of the person and knowing the distance from the foot of the tower to a particular distance, okay, that we can take, let's say for 7 centimeters. Oh, sorry for that, 7 centimeters. We can use the height of the person and then the length or the distance from the foot to 7 centimeters and measure or calculate the angle over here. After knowing that angle, we can use that angle to predict the angle here, predict the angle here, and then we can use that to systematically calculate the height of the tower. Well, we'll look at that later. So what is trigonometry? And if I were to be in a classroom with you, I would have asked you to turn to your partner and discuss the following. Have you heard of the topic trigonometry before? What do you know about it? What do you expect to learn from the topic? Which area of mathematics do you think this topic is going to hinge on? You can pause the video and think about these questions. Now let's progress. Trigonometry is derived from two Greek words, trigonon, metron. And what does that mean? Trigonon simply means triangle, and metron means measure. So my question is, then what is trigonometry? If we are saying trigonon means triangle and metron means measure, you can pause the video and define to yourself trigonometry. Good. I'm sure you said trigonon plus metron means trigonometry. That means trigonometry therefore deals with measurements of triangles and the relationship among the sides and angles of these triangles. So what we are trying to learn in trigonometry is all about we having a triangle, that is the trigonon, and we trying to measure the angles and then the size of the triangle. So everything about trigonometry is all about we measuring angles, we measuring size of a triangle. And here we are not going to use rulers to measure them or protractors to measure them. We are going to calculate them, and that is the uniqueness about trigonometry. Why then do we need to study trigonometry? I've just mentioned one already. If you go to the world of astronomy, they use a lot of trigonometry to do calculations to know the distance of the star and then the distance from the sun to the earth and all those stuff. They are able to measure using trigonometry. If you come to navigations and surveying, people who deal with the land surveying and then they navigate and stuff, they also use um, trigonometry. In submarine and those who work under the sea to know the distance from the depth of the sea to the surface, and the planes and all the um, astronauts, they also deal with trigonometry to calculate, know the angles of their directions. So my question next for you is, what instrument is used to measure angles? I believe you know this from primary school through GHS up to secondary school. And angles are measured in what unit? Angles are measured in what unit? You can pause the video, say the answer, and resume. So here we are saying that in trigonometry, angles are measured in degrees. They are measured in degrees, and they are measured in the direction of anti-clockwise. Take note of that. It's always measured from anti-clockwise, starting from the x-axis. Starting from the x-axis. That is, when we start from the x-axis, we start from 0, then we go anti-clockwise to 90. Then from 90 we come to 180, 270, and back to 360. So we can even come and end 360 here, which will be called one revolution. That means we go around one complete revolution. So that is how we measure angles. So angles are also measured in radians. Angles are also measured in radians. That is starting from 0 radian up to 2 pi radian. Those of you who are doing elective maths, you look at this later when you are having elective maths trigonometry. You go detail into how to convert angles from degrees to radians and from radians to degrees. And we are saying that radian simply means, one radian simply means having the length of an arc being equal to the radius of the particular circle, and then we get the angle here to be called 1 radian. Maybe I don't want to bother the core students so much of that. Now let's come to right angle triangle. You know, we said that trigonometry deals with measurement of triangles, but then even though we have different types of triangles, equilateral triangle, scalene triangle, and the rest, we are going to predominantly base on right angled triangle in the whole course of trigonometry. So I want you to pause the video and write down everything you know about right angled triangle. Write everything you know, and then let's resume. Now this is a triangle. What type of triangle is this? You might think it's right angle triangle, but that is not true, because there's no indicator that shows that it's a right angle triangle. Based on what you've written for yourself, you would realize that we are saying right angle triangle is only right angle triangle if the triangle does have one of 8 interior angles to be 90 degrees. So if I don't show this particular sign of 90 degrees, don't ever talk of right angle triangle until you see that one angle is 90 degrees. Then you can say it is right angled triangle. The side opposite the right angle triangle, or the right angle, that is the 90 degrees here, the side opposite the 90 degrees, which is this side, okay, this side, we call it hypotenuse. And that is the only side that has got a name. It's called hypotenuse. The side over here has no name, the side over here has no name, until we make a reference to an angle. So if I make a reference here and I call this angle theta, then we can say the side here will be the opposite of the theta, and the side here will be the adjacent of the theta. And the same thing, if I put an angle here called theta, okay, then we can also think of the side here being opposite, and then the other side becomes adjacent. What will happen if two of these interior angles are 90? If the right angle triangle is here, and this is 90, and here too is 90, what will happen to this? Well, I believe you know what to say for that. The other two acute angles can be best termed as what? So far as this is 90 degrees, there's no way the angle here can be 90, or this can be 90. And these two acute angles, which is supposed to be acute, because once here is 90, the two angles here must automatically be acute angles. and we normally call them complementary angles. So they are complement to each other in right angle triangle. So that is a summary of what I'm talking about. So if I have the reference angle here, then we can say opposite, we can say adjacent. And if this is also a right angle triangle and theta is here, then this becomes the opposite and this becomes the adjacent. So let's end this video here and then do a quick oral test. Okay, a quick oral test. Trigonometry comes from the Greek words. Mention the two Greek words. All right, I'm sure you said trigonon and metron. The Greek word trigonon means what? You can pause the video and see the answer before you resume. Good. The Greek word metron also means what? Measure. That's true. All right. Mention 3 applications of trigonometry. I'm sure you've said the correct answer. That's true. Surveying, navigation, astronomy, and so on and so forth. Number 5. What is right-angled triangle? I'm sure based on what I just gave you, you can answer that question. And finally, let me ask the last question. Difference between right-angled triangle and isosceles triangle. Differentiate between right-angled triangle and isosceles triangle. I'm sure your answer to is right. That right angle triangle has got one of the interior angles to be 90, but isosceles triangle has only two sides of it, angles equal and size equal. It has only two sides equal and two angles equal. So with this, we come to the end of the introductory part of trigonometry. In fact, you can go over the video again and make sure you understand every term we've used in getting to this far. Our next video, we are going to look at trig ratios and how we can apply it in solving questions. Thanks so much for choosing Maths Clinic series. Stay blessed.